All right, so the probability of the complement of an event. So if probability of complement of A का मतलब ये होता है कि what's the chance that A does not occur. Okay, that's what complement of A means. Okay, and this is equal to 1 minus the probability of A, because have a look. So let's say this is your S and this is your A. A complement is everything here. Okay, this is A complement, and we know that probability of S is 1. Yes, and so what is S? S is this joint union of A and A complement, right? So it's probability of A plus probability of A complement, and it must be equal to 1, which implies that probability of A complement is, अगर मैं इसको दूसरी तरफ ले आऊँ, it's 1 minus probability of A. Okay, so if you want to compute the probability that A does not occur, you just need to compute the probability that A occurs, and then you subtract that probability from 1. Okay, and again I say here that it's a very easy to use formula, and the tough part is to figure out what does the complement of an event mean. We'll see a couple of examples. So here's probably the first example. You have a sequence of 10 bits uniformly generated. Okay, so each bit is uniformly 0 or 1. Okay, each bit के 0 होने की probability भी 1 over 2 है और 1 होने की probability भी 1 over 2 है. And the question is, what's the probability that at least one of these bits is 0? So let me sort of get you started. Okay, so A is the event this, that at least more than one bit is, more than or equal to one bit is 0. Okay, and I would like to ask the question, what is the event A bar?
No bit is zero. Every bit is zero.
Yeah, so none of the bits are 0. None of the bits are 0. If none of the bits are 0, what does it mean? All bits are?
One.
All
1.
bits are 1. So A complement is easy to compute. What's the probability of A complement?
1/10 की power 10. 1/10 की power 2.
1
So
by 2
there,
raised by
1/2 की
10.
power 10.
yeah.
1 by
So
2 raised
there,
by 10.
yeah. So there are 2 raised to power 10 possible bits that you can generate, and each one of them is uniformly likely. So the size of the sample space is 2 to the 10, and there is only one combination. This may you get all ones, right? This is only one combination among these which is equal to this. So this probability is just 1 over 2 to the power 10. And so the probability of A is going to be 1 minus the probability of A complement, which is just 1 minus 1 over 2 to the power 10. Okay? All right. So this maybe this question was slightly harder to do if you didn't know the complement formula. But if you know the complement formula, then it's usually you should try it. Okay? अगर आपके पास कोई problem है and you have problem and you ran into troubles computing probability of the events, it's a good idea to try to compute the probability of the complement of that event. Okay? जैसा कि मेरे ख्याल में someone suggested to do it on a previous problem. कौन सी problem थी? Can you remind me? We can try to do it now.
सर वो
Queen वाली
Queen of
Note out था जो.
Let me try to. Where is it? Let me know when we reach there.
It's a note of Queen of Heart.
it's in the bottom. यहाँ से नीचे
ये वाला?
नहीं इससे नीचे थी.
इससे भी नीचे है
नीचे थी सर. ये थी. Yes.
What's the probability that a 5 card does not contain Queen of Hearts? Okay. Okay. ठीक है. So let's try to do this. So I'm actually not sure that we will be able to do it. Let's see. So A event says that 5 cards don't contain contain Queen of Hearts. Okay. Um, so what is A complement? So what's the A complement event?
At least one of the
Five
cards
cards
is
are
queen.
contained.
Yeah. So one of the cards is Queen of Hearts. Okay. Actually, this is not that hard to compute anyway. Okay. So S हमने शायद किया था. S remains the same. The size of S is 50. Choose 5. You choose 5 cards randomly. What is the size of A complement?
There are 52 cards.
Oh, there are 52 cards. Okay, yeah, good. So what's the size of A complement? Actually, oh, who was it? Who suggested it in the first
Yeah,
place?
so I suggested Ehsan, but it wasn't like this. मैं ये कह रहा था कि हम ए को कैलकुलेट करने का एक डिफरेंट तरीका है.
Yeah, that's what we are doing. We are computing A. So A complement says that one of the cards is Queen of Hearts. So great, one of the card is fixed now. Okay, you are left with 4 cards. So it should be 51 choose 4. Okay, so you pick 51 choose 4. So that should be the size of A complement. I think this is what it should be. Uh, so the probability of A would be 1 minus the probability of 51 choose 4 divided by 52 choose 5. Okay. और हमने उधर क्या probability निकाली थी? Where is it? It was 51 choose 5 divided by 52 choose 5. Do I get it here? So you have 50.
This is
Choose
47 by 52.
uh,
Does it seem right?
just give me a second. Let me think about it. Let's try doing anyway. Okay. So it's 52. Choose 5 minus 51. Choose 4. Right. Divided by 52. Choose 5. Okay. What do we get? We had 52 factorial divided by
Right?
5
Should we not be
factorial.
considering the probability of having a queen of hearts? You're like completely disregarding that.
So in this event, we have to choose 4 cards. The 5th card is fixed.
Yes,
Okay.
but like, isn't it the card has its own probability of occurrence as well? So
No,
should we not be
it is
regarding?
not. So there is only one Queen of Hearts, right? It's gone.
Yeah.
So it's
Okay.
not there now. Okay. So that's fine. So this is 47 factorial. और इसमें से हमने करना है 51 factorial divided by 4 factorial times 47 factorial. So let's see what can we pull out. We can pull out 51 factorial divided by 4 factorial and 47 factorial. This we can pull out, and we are left with 52 over 5. Minus 1. Is this correct? So there's 51 factorial here, and there's 4 factorial, 47 factorial, everything is gone. So you're left with this. Okay, let's do it again. So you get 52 minus 5 over 5, and you are
Sir, the way we were doing it before, like that gives us the probability of choosing a queen of hearts, right? So if we like subtract it from one, it gives us the probability that we do not have.
yes.
the queen. So like, doesn't it make it 3 by 47 by 52? 47 by 52 instead. The probability of having a queen of hearts in the hand.
Uh, oh, sorry. Which part do you think is wrong? This A complement?
We were doing it fine earlier, like in the beginning when you subtracted 1 minus 51, choose 4 divided by 52, choose
Okay.
5. It was
Okay.
fine.
Okay. So where's the problem?
There is no problem.
Okay. Okay.
So
Let's
why are we like
finish.
computing it again?
We're just expanding it, I think.
Oh, we
Okay,
are expanding it. We are trying to get the same answer. We are trying to see if
okay,
this all this comes out to 51 choose 5.
okay.
Which
So
I
we
don't
could
know if.
just put this in a calculator and see if the answer is the same.
Okay. Do you do I occur like a calculator guy to you? Um, okay, let's see. Um, ठीक है, let's see where are we. So this gives 47. I'll get rid of 47, and I would be left. There is a 46 coming out. What's wrong with the 46 thing? So this is 51, and this is 47. Okay, and I have 5 factorial here. 5 times 4 आ गया और नीचे I have 47 factorial. Okay, so this gives me the answer of 51 choose 5. Okay, so it's 51 factorial divided by 5 factorial and 46 factorial. Okay, which is 51 choose 5. Okay, that's it, right? That's what we were looking for. It's 51 choose 5. The size of your entry. Yeah, it's same. Okay, so you can solve it using the complement as well, but but it's probably slightly messy to expand it. Okay, so here's all the work, all we needed to do. We get the same answer. All right,
Sir, I have a question.
sure.
So the question was like, what is the probability of not having a queen of hearts in a hand of
Yes,
5 poker cards, right? So
yeah,
can we not do it in a way that we fix the queen of hearts at a side, and then we have like 51 possibilities?
yeah,
So that makes 51 choose 5 for the cards without the queen,
yes.
and the total sample space is 52 choose 5. So isn't it simple to compute like 51 choose 5 divided by 52 choose 5?
It's much simpler, and I'm on board for that. That's exactly what we did here. But Abdur Rahman, I don't know whoever was there. He said that we should do it using compliments, so we did it just to uh, appease his curiosity. Okay.
Okay.
And I'm grateful for that, sir.
It's all right. It's good. It's a good exercise. Okay. Um, all right. So where were we? So we were doing the complements. ये वाला हमने problem कर लिया था. And let's try doing this. A sequence of 10 bits, uniformly random. What's the probability that at least one of these bits is 0? We did it, right? The same slide. We did it. Okay. What's the probability that a positive integer selected at random from a set of positive integers not exceeding 100, so numbers from 1 to 100, is divisible by either 3 or 6? So you pick a number, okay, positive integers from 1 to 100. And the question is, what's the probability that it's not divisible? Oh, it is divisible by either 3 or 6. Size of the sample space is, hello,
100.
100, yes. And what's the size of numbers that are divisible? How many numbers are divisible by 3 or 6 in the first 100 numbers?
33.
Yeah, so if you want to compute the numbers which are divisible by 3 in range from 1 to 100, it's usually easy to do by doing this. Okay,
More.
divided by 3, take a floor. Okay, so there are 33 numbers that are divisible by 3, and there are, I don't know, this many numbers, probably 18, uh, 17, 16, 16 numbers, okay, which are
Yeah,
divisible by
16
6.
numbers.
Okay, so what's going to be the size of this event A? That your number is divisible by 3 or 6?
33 by 100 plus 16 by 100.
No.
No, sir.
Exactly, because
33
the
over
number
Oh, it is either 3 or 6. Okay, yeah.
Yeah.
all numbers
So if it's
divisible
divisible
by
by 3, it's definitely divisible by 3. Sorry, if it's divisible by 6, it's definitely divisible by 3, right? So we only need to compute
Yes.
the numbers which are divisible by 3, which is 33 over 100. All right, is everyone on board?
Yes, sir.
Yes, sir.
Okay, okay, so it's a trick question. This one is not a trick question. It's a genuine question. You need to compute the probability that the number is either divisible by 3 or it's divisible by 5.
सर इसमें हमें वो इंक्लूजन एक्सक्लूजन वाला निकालना पड़ेगा बिकॉज
Yes, good. Okay, so let's say that A is the event that X is divisible by 3. Okay, and let's B be the event that. Why am I writing everything? I am a discrete math professor. I should write it like this. Okay, 5 divides X. So these are the two events, and I'm interested in the probability of A union B. Okay, either it's divisible by 3 or 5. Okay, and we know that this is equal to this, और फिर हमने इसमें से subtract करना है A intersection B. Okay, what's the probability of A? It's divisible by 3. It's just
33.
33 over 100. Yes. And what's the event probability of B?
20 over 100.
20.
Yeah, it's 20 divided by 100. And what's the probability of A intersection B?
6.
15.
So so
Yeah,
it's the event that the number is divisible by 3 and 15. Okay, which means that it's a number which is divisible by 15.
15.
Okay, so it's what is it, 6?
6. Yes, 6.
Yeah, it's 6 over 100. Okay, you put these numbers in here and you will get your answer. Okay.
47.
Okay. Yeah, it's 47. All right, so that's, I hope everyone is on board. Uh, but you need it to apply the include and exclude principle here. Okay. Here is one more question, and I'm probably not going to completely solve it, but I'm going to give you heads. So I'm interested in the probability of A union B union C in here. Okay, there are 3 events here. So I would rather need probability of A मुझे चाहिए होगा, फिर मुझे probability of B चाहिए होगा, फिर probability of C चाहिए होगा. Then I would need to subtract probability of A union B. Then I would need to subtract probability of B union C. Then I would need to subtract probability of A union C. Sorry, union नहीं है, यहाँ पे intersection है.
Section is
Yeah. This is intersection here, boys and girls. This is intersection. This is intersection. Okay, so it's intersection there. So A intersection C. And then you need to add probability of A intersection B intersection C. Okay, and each one of them is easy to compute, right? A is numbers which are divisible by 3, B are numbers divisible by 5, A intersection B is number divisible by 15, B intersection B is numbers divisible by 40, A intersection B is numbers divisible by
24.
24. Yeah, A intersection B intersection C is numbers divisible by 5 into 120, right? So these are numbers divisible by 120. And I think none of them are there. But I just wanted to give you an example in which you have three of these numbers, then you can apply this extended inclusion exclusion principle, which we have seen in counting before.
सर इसमें एक पॉइंट है कि if it was 4 or 6 we would take the LCM of them, not multiple, right? जब हमने माइनस करना है.
Yes, okay, that's a good point. If you have numbers, for example, over here you have let me just try to figure out an example. Let's say you have so for
4 or
example, if you have no, what
4 or
Beta?
6.
If you have 4 and 6, so yeah. So if you have numbers 4 or 6, so here you need to find out. So if you find out intersection B, तो फिर यहाँ पे it's not 24 से नहीं करना, आपने 12 से करना है. Okay, everything that's divisible by 12 is divisible by 4 and it's divisible by 6. Okay, so you have to take their smallest common divisor, multiple factor. Okay, the LCM, which is 12. Good point. All right, this is an interesting problem. I'm going to leave you here. The problem is, and it's sort of very famous. Okay, you guys probably have already heard about it. The problem is that you go to a TV show and you have these three doors in front of you, and one of them contains a car. Okay, इस तरह की कार है. I mean, इस तरह की नहीं है, it's अच्छी वाली कार है. और यहाँ पे you have a, what do you have here? कुछ भी नहीं है, empty है. ये भी empty है और ये भी empty है. Okay, but you don't know which one of them is empty and which one of them contains a car, and you are, let's say, a car freak, and you are like you really want a car. Okay, so let's say you randomly pick a door. Okay, so you, for example, pick a door. I don't know, whichever you pick. Okay, let's say you pick the first one. Then what the host does is he reveals one of the other doors. Okay, since only one door contains the car, there is at least one door which is empty. Okay, तो वो ये वाला door आपके लिए खोल देता है. Okay, and he shows you that this door is empty. Now he gives you an option to switch your door. Okay, the question is, should you change the door, or should you keep your original selection, and does it matter or does it not matter? Okay, switch करने से कोई फायदा होगा या नहीं होगा, और क्या नुकसान तो नहीं होगा? That's the question, and it's a probability question. You assume कि जो पहले दफा आपने पिक किया डोर वो randomly पिक किया, or that's the question. Okay, so I'm gonna leave you here and we'll talk about it next time. But I would recommend not reading about it. What you could read about is actually the chapter, I think 9 in your book, जो आपकी original book है, रोजन की book, उसमें जो probability का chapter है, उसका जो first part है, I think it's chapter 7, okay? जो 7.2, yeah, it's chapter 7. जो 7.1 है, it's a whole section dedicated to the uniform probability. Okay, तो वो यूनिफॉर्म प्रोबेबिलिटी के ऊपर बात करते हैं. द 7.2 है, उसमें वो जनरलाइज प्रोबेबिलिटी की बात करते हैं, जिसमें करेक्ट डेफिनेशन है उसकी. तो आई वुड रेकमेंड कि उसकी आप एक्सरसाइजेस देख लें, और लेट मी नो इफ यू रन इनटू exercises that you find challenging, and we can do them in the class on Monday as well. Okay, and also I'm going to remind you about the feedback form. If you haven't done it, go ahead, do it right now, and provide a constructive feedback. Looking forward to reading those feedbacks. Thank you, guys. See you on Monday. Okay. Okay.
Okay, sir.
Goodbye.
Allah Hafiz, sir.
Allah Hafiz.